2.3 Remainder and Factor Theorems. So before we get to the remainder and the factor theorem, we're actually going to go back in time and look at long division. The process that we use for long division of numbers is the same process we're going to use to divide polynomial functions. So I'm going to go through this step at a time and just remind you of why you do certain things within the long division process. So I want to divide 512 by 11. So I start by comparing the number on the outside, 11, to the first digit on the inside. And I know that 11 doesn't go into 5. It's bigger than 5. So then I go to the next term over, and I want to see how many times does 11 go into 51, or 11 times what would be close to 51. So 11 times 4 would be pretty close to 51. So I put a 4 on the top. Then I'm going to multiply 4 times the 11 on the outside. So 4 times 11 is then 44. And then we always drew a line and we did subtraction here. It was always the opposite of whatever number. And for a long division of numbers, it was always a subtraction symbol. So then 51 minus 44 was 7. So then you brought down the number that was in the next place, in this case a 2. So now I want to compare, and I'm going to see 11 times what could equal 72. So I'm going to try 6. So then again I multiply 6 times the 11 and write it down, and then I'm going to subtract that from 72. So 72 minus 6 is 6. Now I've run out of numbers, but I'm not finished dividing. So you can add a decimal and another 0, and we bring the 0 down. So now I want to see 11 times what could equal 60. So 5. So 5 times 11 then is 50, and we're going to subtract. That would leave us with 5. I'm going to bring down another 0. So 11 goes into 50 4 times. 4 times 11 we know is 44. So I could keep going like this as long as I needed to find the rest of the answer. This one turns out that the 54 is repeating. Okay, so I wanted us to look at the process that we use, why we multiply, why we subtract, that sort of thing, because we're going to be doing the same thing when we use long division of polynomials. Alright, so we're going to use long division to divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. So same as the previous problem, the x minus 2, what we are dividing by, is going to go outside. What we are dividing into goes inside. Okay, so we're going to go step at a time again so that I can explain exactly what we're doing and why we're doing it. So I always want to compare first term into first term. So we're only going to look at x into 6x cubed. So I want to know x times what could equal 6x cubed. Well, x times 6x squared would equal 6x cubed. Okay, I don't have to worry about the minus 2 or the minus 19x squared and all the rest of the stuff. We're just comparing first term into first term. Okay, so then I'm going to multiply back. And when I multiply back, I multiply times everything on the outside of the division symbol. So we just said 6x squared times x is 6x cubed. And then 6x squared times negative 2 is negative 12x squared. Then we're going to draw the line and change all of the signs. Previously, when we were dealing with just numbers, we had one number there and we changed it to subtraction. We're doing the same thing. We're changing to subtraction, which would change any signs that are already there. Okay, so now we're going to add straight down. And your first term should always cancel out. That's what we're looking for. If it doesn't cancel out, then you didn't pick the correct number to multiply by on the top. So my cubes are gone. Negative 19x squared plus 12x squared is negative 7x squared. I'm going to bring everything down, plus 16x minus 4. So now again, I'm going to compare first term into first term, and I want to know x times what equals negative 7x squared. So that's going to be negative 7x. So I'm going to multiply negative 7x times both terms on the outside, which will give me negative 7x squared plus 14x. There's my square. Draw the line and change all the signs. So again, my x squareds are going to cancel. Positive 16x minus 14x is going to give me 2x minus 4. Okay, again, x times what equals 2x? Well, that's going to be plus 2. So now I multiply 2 times everything on the outside, so that's going to be 2x minus 4. I'm going to draw the line and change all the signs. This time, when I subtract, I have a remainder of 0. So if you were doing long division of numbers and you got a remainder of 0 at any point, that's when you knew how to stop the problem. Same thing here. Okay, so the answer to the problem dividing this polynomial by this binomial is 6x squared minus 7x plus 2. When you get a 0 remainder, this means that whatever you were dividing by, x minus 2, is a factor of this polynomial, and x equals 2 is a 0 or a solution. Okay, so that's how I know I did something right, is when I get a remainder of 0. So then I could take 6x squared minus 7x plus 2 and factor it further and find the other zeros, the other factors of the problem. Okay, so we're going to try another long division. This time we're dividing a polynomial by a polynomial. So I notice in the top polynomial I'm missing some terms. I'm missing an x cubed and an x. When you're doing long division and you're missing terms, you need to put a placeholder in there. And you'll see why when we start actually dividing in a second, that it's important that things line up in the correct spot. Okay, so again, even though it looks scary because there's so many terms, we're just comparing first term into first term. So I want to look and see what times x squared equals x to the 4th. So x squared times x squared equals x to the 4th. Now I'm going to multiply x squared times everything on the outside. So x squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times 3 is plus 3x squared. I'm going to draw the line and change all the signs. My x to the 4th's canceled. I'm going to have 2x cubed plus 0x squared. And I'm going to bring everything down, plus 0x plus 1. If you noticed, if I hadn't put the 0x cubed and the 0x, all those terms would be shifted to the left, and I would have a 3x squared on top of a 2x cubed. And I might be tempted to add those terms that are not like terms. So it's important that you have the placeholders to keep all of your terms lined up in the correct place. Okay, so again, we're going to compare x squared and 2x cubed. I need to know x squared times what equals 2x cubed. Well, that's going to be 2x. So I'm going to multiply 2x times everything. So that will be 2x cubed. 2x times negative 2x will be negative 4x squared. 2x times 3 will be 6x. We're going to draw the line and change all the signs. Okay, so my cubes cancel. I'm going to have 4x squared minus 6x plus 1. So again, I need to figure out x squared times what equals 4x squared. So that's going to be plus 4. Multiply 4 times everything on the outside. So that's going to give me 4x squared minus 8x plus 12. Draw the line and change all the signs. X squareds cancel. I'm going to have 2x minus 11. Okay, so again, I need to see x squared times what will equal 2x. Well, there isn't anything that I could multiply x squared times 2x because x squared is a bigger term, a higher exponent than 2x. So in this case, I did not get a remainder of 0. So for the remainder, 2x minus 11, I need to add that to the end of my answer. So I'm going to put plus 2x minus 11 over what we were dividing by, x squared minus 2x plus 3. So in Algebra 2, you may have just put r and then the number 2x minus 11. This is correct to write both ways, but I would prefer that you write it like this, as a complete polynomial dividing by the original polynomial. Again, because we did not get a 0 remainder, this means that x squared minus 2x plus 3 is not a factor of the top polynomial. Okay, so now we're going to use synthetic division to divide polynomials. Synthetic division only works when dividing by a binomial. It would not have worked on the last problem, so you have to be able to divide by a binomial to use synthetic division. So for synthetic division, it's just a shortcut way to divide the polynomials where we kind of eliminate the unnecessary parts, which would be the variables. We're just going to look at the coefficients. So we're going to take the coefficients of the first polynomial that we're dividing by, or that we're dividing into. We're going to write those down. So 3, negative 17, 15, negative 25. We're going to solve the binomial that we're dividing by. So x minus 5 is the same as x equals 2. I'm dividing by 5, so I'm going to put a 5 over here in a box. And then I'm going to leave a row of spaces underneath these coefficients and draw a line. Okay, so with synthetic division, the first term gets brought down automatically. We're always going to multiply what's underneath the line times what's in the box. The answer goes in the next space above the line. So 3 times 5 is 15. Then I'm going to add negative 17 and 15, which equals negative 2. Multiply negative 2 times 5, which is negative 10. 15 minus 10 is 5. 5 times 5 is 25. Negative 25 plus 25 is 0. Okay, with all the other polynomials that we've divided, our answer was always one less exponent than what we started with. Same thing with this problem. We're dividing x cubed by x, so our answer is going to start with an x squared. So we plug in the variables. So 3x squared minus 2x plus 5 is the solution, or when we divide this polynomial by x minus 5, this is the answer. Because I got a remainder of 0, this means that x minus 5 is a factor, and x equals 5 is a 0. Okay? I could take 3x squared minus 2x plus 5 and factor it further, or solve using the quadratic formula, to find the other solutions to this polynomial as well. Okay, we're going to do one more. 5x cubed minus 6x squared plus 8 divided by x minus 4. So this time, notice I'm missing a term. I'm missing the x term. So I need to put a placeholder. So 5, negative 6, 0 x's, and then 8. Got to have a placeholder there. We are dividing by 4. Whatever we're dividing by, take that binomial, set it equal to 0, and solve. That tells you the number that you're dividing by. Or it's always going to be the opposite sign of that number. Okay, so the first number gets brought down, 5. 5 times 4 is 20. Negative 6 plus 20 is 14. 14 times 4 is 56. 0 plus 56 is 56. 56 times 4 is 224. The plus 8 is 232. So our answer for dividing these two polynomials, start with the next lowest exponent, would be 5x squared plus 14x plus 56. Since I did not get a 0 on here, this means I have a remainder, so plus 232 over what we were dividing by, x minus 4. Now, since I did not get a 0 remainder, this means that x minus 4 is not a factor, and x equals 4 is not a solution or a 0. Okay, here's just a little bit of important information using synthetic division and long division. Here's some facts about that. So if r is the remainder after dividing, then the following is true. R is the value of f of c. So this is a shortcut to plugging into a function. If you want to know f of 2, that means plugging 2 into x for the function. It's the same thing as if you use synthetic division dividing by 2. The end result, the remainder, is that function value. Now, I wouldn't use this very much. I think it's easier just to plug into the function than to use synthetic division. But it's just a fact, something that actually works with synthetic division. Next thing, if r is 0, then x minus c is a factor of that function. That means that c is the x-intercept, and x equals c is a solution, a root, and a 0 of that function as well.